Okay, Assalamualaikum and very good morning. In class, we will proceed on chapter 8 about ordinary differential equation, specifically in second order range quota Heun method. Okay, as per previous class, we already learned about how to identify the ODE or ordinary differential equation by using Euler method and midpoint method. Now we will proceed on Heun method. So straightforward, consider an initial value of first order ordinary differential equation. Let's say we have equation like dy dx or equal to f x or y, or you can also note as a y prime. Okay, in this case, when x naught or x 0, then y is equal to y naught. Okay, by using Heun method, the solution is given by 4 equation. This one, first, second, third, and fourth equation. Okay, I zoom a bit larger for your more clear. Okay, for the first equation, actually, this is the function given from the question. Okay, so you can might write down as a f x y or y prime x. Okay, and then the second one is how you are going to get the next value of y. Okay, y plus 1. Okay, this is the latest value of y. Okay, by the current the current value of y is plus 1/4 of k1 plus 3 3 over 4 k2. And the third equation is about how to identify the k1 is by multiply h multiply by this one is the function of y prime y. Okay, okay, let's say this one, dy dx, okay, also known as a y prime, okay, also known as f x y. Okay, let's say ds over dt, okay, also can be known as a okay, s prime or f t over s. Okay, let's see what else can be d. Okay, maybe the pressure over time. Okay, can be pressure prime over f. Okay, t pressure. It can be is referred on the question given. Okay, okay, then we go to the example 8.3 from the question. Given the initial value problem is x y prime minus y equal to x over x plus 1. So in this case, okay, you have to rearrange the equation to identify the y prime. Okay, y prime is equal to dy dx. Okay, what is it? So and then okay, with the condition of y1 equal to 0 means that, okay, when, okay, this one meaning that when x equal to 1, y equal to 0. So you can state like this one. Okay, when x equal to 1, y equal to 0. Okay, so our iteration will be start from x equal to 1 until certain value lah. So and then in the question A, okay, example 8.3a, solve the initial value problem for x equal to 1 bracket 0 1. So in this case, what they are asking you is, okay, when x, okay, I 0.1 to 1.4 means that you have to iterate from 1 until 1.4 with the h with the step size is 0.1 means that start from 1.0 1.1 1.2 1.3 and 1.4. This is the meaning of this statement. Okay, using Heun method, and find the absolute error if the exact solution is yx equal to x ln 2x over x plus 1. So this is the exact solution formula, which is you might use after the second iteration of this of the question A. Okay, question A. After you complete this equation A, the question A, and then you will have to identify the absolute error by comparing with the exact solution. Okay, we go for the solution. Okay, this is the original formula or original function given. Then you have to rearrange by using this one. So in this case, after you rearrange, then you might get this one. Okay, x over x plus 1, okay, plus y over x. Okay, in this case, we straight to the k1 and k2. So please, class, please remember about this table. Okay, okay, table of Heun method. Okay, in this case we have I iteration, and then start from 0, 1, 2, 3 and 4, and x is starting with 1 until 1.4, and then the step size h is 0.1. Okay, 0.1 until 1.4, and y, okay, from the question here, the one is, okay, y is 0, the initial value is when x equal to 1, y equal to 0. So this value you should put here. Okay, y, okay, when x equal to 1, y equal to 0, and then for those k1 and k2, you just straightforward substitute from this equation. Okay, from this we know that the h value is 0.1, and then this is the equation or function from the question. Okay, so you just key in your calculator, and then when the calculator asks about the value of x and y, so you just copy this one. Okay, x is equal to 1 and y equal to 0. Okay, and then you will get this number, this value. Same goes to k2. Okay, for k2, okay, first you we know that the h is 0.1, and then we key in the calculator. Okay, key in the calculator 0.1. Okay, this one, like this one, 0.1, and then multiply by x, okay, plus 2, this, in this case h is 0.1, so you just multiply that first lah. Okay, divided by 3, and then y plus 2k1 over 3. So based on the equation given, so any x value, any x, you have to, in this case, any x value you have to plus 2h over 3. Any y value, you have to plus 2k1 over 3. Any, okay, let's say in this equation, okay, any x, you have to x plus, okay, 2h over 3, any, okay, any, same goes to this one, okay, but okay, same goes to this one, okay, and y, I change color, and okay, I think more darker, okay, any y, you have to plus y I plus 2k1 over 3, any, so any y, okay, you have to plus 2k1 over 3, okay, in this case we will get this kind of value 0.054738. So in some cases our calculation is up to 4 decimal, but in this class I would like to approach until 6 decimal number, okay. And then for the exact is based on you just compare with the exact value, okay. In this case since we are using 0, then we got 0, okay. And then this is the absolute error, okay. And then next, for y equal this one, this number, how we are going to get this number is based on this equation, okay, on this equation, okay. Y I plus 1 is equal to y I plus 1 over k1 plus 3 over 4 k2. So you just use this equation, okay. Okay, this is the equation to identify the current value, the latest value of y. So in this case y, this one 0.053554 is equal to yi. Yi is 0 plus, okay, 1 over 4 k1. K1 is 0.05 plus 3 over 4 k2. K2 is 0.054738. So and then we will get this number 0.053554. Okay, and then for the K1 and K2 same, okay, and then you will get this number. Okay, how about the exact value, okay, the 0.051172 and 0.02382. Okay, in this case, to identify the exact and absolute error are based on this equation, okay. Okay, so in order to identify the exact value is 0, you have to key in your calculator, okay. X is equal to 1, so 1, and then ln, okay, 2 1, okay, over 1 plus 1, okay. So and then you get the value is 0 as here. And how we are going to get the absolute error are based on this value, okay. You have to minus, okay, this value, the y value, so you will get 0, okay. And then same goes to the others iteration. In this one, for exact value you just change the value of x from using 1.1 value. So you will change this one to 1.1 ln 2 multiplied by 1.1 divided by 1.1 plus 1, and you will get the number. The value is 0.051172. Okay, this one. Then how to identify the absolute error? Based on this number 0.051172, you have to minus the numbers of this one. Okay, and y, okay, 0.053554 in absolute manner. So you will get the difference is about 0.002382. Same goes to others iteration. Okay, so next we will proceed on